right, 4.3, we're going to talk about greatest common divisors and least common multiples, which is things you've talked about before, right? You've heard of these items before, just like this divisibility concept. Sometimes you hear greatest common divisor. Instead of you hear the word divisor, you hear the word factor. It just depends on the text you're using. Either one is fine. So you'll see that, in fact, when I wrote it down, greatest common divisor GCD or greatest common factor GCF are used interchangeably because divisor is exactly the same as factor. And all a greatest common divisor is it's the greatest whole number that divides all the numbers you're looking at, whatever that group of numbers is. So if it's two numbers, it's the greatest common divisor of those two numbers. If it's three numbers, the greatest common divisor of those three. And then if you have two numbers where their greatest common divisor is 1, then they have a special name. They're called relatively prime. And at different points, I've used this idea, and in fact, in the homework that you encountered, hopefully you ran into this idea as well. You were looking at numbers, in fact, we talked about the divisibility test for 6. 6 is 2 times 3, right? So when 6 is 2 times 3, we can do that and look at just the divisibility test of 2 and the divisibility test of 3, because 2 and 3 actually, not because they're prime, but because they're relatively prime. It means they don't have anything in common with each other. So, again, for an example, if I wanted to find out if a number was divisible by 24, as an example that came out in your homework, 24, I can divide 24 into 4 times 6. Okay, but the problem is that 4 and 6, they're both divisible by a number 2, right? Well, the number 24 can also be divided into 8 and 3. Agreed? So I could actually test whether something's divisible by 24 by testing if it's divisible by 8 and divisible by 3. And because 8 and 3 don't have anything in common, it will work. Okay? Because they're what we call relatively prime. And in fact, neither of them actually have to be prime for them to work. They just have to be relatively prime to each other. Again, that just means they don't have any factors in common. So let's take a look at several different methods for determining if and when we actually have a greatest common divisor. So the first method is the intersection of sets method. And the way that this works is you actually list all of the factors of each of the numbers you're looking at, and the biggest one is your greatest common factor. Okay? So factors of 12. Well, I've got 1 and then what? 2, 3, 4, 6, and then 12. Okay, so this is the number 12. How about 15? 1? Okay. And the biggest number that's common in both lists is? 3. Will there always be a number that I get to circle? Yes, 1. Marissa's right. There's always going to be some number, 1, because they always are going to have a 1 in common. Okay? So there's always a greatest common factor. It may not be a very interesting one, but there's always one. So this one, the greatest common factor or greatest common divisor is 3. Oops. Okay, I'm going to do one more and then we'll pause for today. Prime factorization. You have seen this before and we've actually worked with this before. Prime factorization, what you do is you get the prime factorization for each number. And then you look at what they have in common. And everything they have in common is part of the factorization for the greatest common divisor. All right, so we have numbers that are bigger this time, and I am going to go with lists down because that's what I do. 400 is divisible by, smallest prime factor. What is it? 2. 400 divided by 2 is 200. Then I'm going to divide by 2, and I get, and I'll divide by, and I'm going to get, and I'm going to divide by, I feel like one of those auctioneers. And then I get 25, and then 5 and 5. Awesome. We'll come back to this in a minute. Let's do 360. Smallest divisor, 2, and I get 180. That took you guys a little longer. 180. 2, and I get 90. And then 2, and I get 45. And if you're being really careful, that's the next smallest divisor for 45. Smaller. 3 will work. If you don't go in order, it's okay, but 3 is the next smallest one. And I get 15, very good. Was that you, Anna?
Yeah.
All right, 15's right. And then I get 3 again, and then I get 5. Now, what I want to do is I want to actually write out the prime factorization so that I can show what happens with this sort of a description up here. So 400 is 2, 2, 2, 2. I got 4 2's, right? 2 to the 4th times 5 squared. Everybody good with that? Awesome. 360 also has a 2 in it. 2 to the what? 2 to the 3rd times what? 3 squared times 5. All right, so the greatest common divisor takes any prime factor they have in common. So tell me a prime factor they have in common. 2. They both have a 2 in them. What else do they both have?
5.
A 5 in them. But be careful, I'm not done. I need the 2 and the 5. But I need them raised to the least exponent you see in the problem. What is the least exponent on 2? 3. What is the least exponent on 5? 1, or you could just write nothing there right now. Not a 0, but just don't write anything. And then what is 2 cubed? 8. 8 times 5 is 40. The greatest common divisor is 40. Okay.